In 2002, Emirates Airlines placed an order for 45 of the new Airbus A380s and an equally major order of Boeing 777s. To accommodate these and other additions to their rapidly expanding fleet, the new engineering centre was commissioned. In July 2003, the final design validation was signed with ADPI, a French consultancy firm specialising in aviation building design, and the main contract package was awarded to Joannou and Paraskevedes in December of the same year. Catering for aircraft parking, docking and maintenance, the engineering centre is located northeast of Dubai International Airport. It is split into 9 different areas, consisting of 7 heavy and light maintenance hangars, a painting hangar, workshops and stores, internal access road, engine run-up facility, administration offices, central power plant, multi-storey car park, and external groundworks and services. The earlier addition of PVC tubes to the reinforcing cage results in a much more efficient means of pile head removal than more common methods, and was adopted by J&P for this. For the services gallery under the internal access road, a shuttering system developed by Utinord was employed. J&P have utilised this system extensively on many of their projects and have found it to be extremely efficient. The required components were manufactured to specification and then shipped to the project, ready for unloading and on-site assembly. Before the Utinord shuttering system could be brought into play, all the services for the gallery area had to be mapped out and prepared. Prior to use, the shuttering had to be treated with a formwork release agent to facilitate the removal after casting of the concrete and ensure that the surface is not spoiled. Once the shuttering was in place and locked off, the surface reinforcing steel was then assembled and the remaining services installed. As supporting columns were specified in the designs, additional reinforcement was required to cater for the shear forces. All of the concrete casting was performed at night, and paraffin heaters were placed inside the shuttered area to accelerate the curing process. The next day, approximately 8 to 10 hours later, the shuttering was struck. Casting 10 meters per day, it took just 120 days to complete the 1.2 kilometers that comprises the services gallery and the floor of the internal access road. Throughout the construction of the engineering centre, a total of 200,000 cubic metres of concrete and 22,000 tonnes of reinforcing steel were required. The design specified a total of 9 20-metre-high gate piers to accommodate the enormous hangar doors. These were founded on pile and the walls were constructed using climbing formwork. The roof structural steelwork sections were assembled on the ground before being lifted into place by crane. In order to achieve the small positioning tolerances for this type of structure, fine-tuning of the upper sections of the supporting columns was implemented. The three main components of the roof were the relatively lightweight space frame sections to the rear of the hangars, the 110-metre centrally located mega trusses, and the 110-metre 350-ton arch trusses. A total of 18,000 tonnes of structural steel went into the construction of the hangar roofing, with a further 9,000 tonnes required for the workshops and 1,500 tonnes of architectural steelwork. Highly trained specialist crews worked around the clock to meet the exacting schedule requirements. Two 400-ton capacity cranes and a further 2 lesser capacity cranes were required to lift each of the major trusses into place. Immediately upon the completion of steel erection for each hangar, the excavation of the underground services within the hangar commenced. These were primary firefighting and drainage pipework, compressed air supply, electrical and data cabling, preconditioned air supply, and other specialized services which are required for the maintenance of aircraft. The beams for the door-bottom tracks had to be designed to withstand the loads imposed by the heaviest aircraft, and loads resulting from 140 km/h winds. The hangar floor foundations were treated with curing compound to ensure the water content was retained within the concrete. For the suspended floors of the workshops and the upper-level internal road, precast hollow core slabs were used. A total of over 4,500 were required for the 40,000 square meters of suspended flooring. The precast hollow core slabs were supplied by a local firm. Further reinforcement was laid before the final screed was poured. For the partition walls, throughout the project, traditional blockwork was employed, with vertical and horizontal reinforcement. A total of 1,200,000 blocks were required for the entire project. The roofing, amounting to a staggering total of 165,000 square meters, is made up of a sandwich of 6 separate layers. These are perforated profile decking, a layer of high-density fiberglass insulation, a polyester film vapor barrier, a layer of low-density fiberglass, and a second layer of low-density fiberglass with reflective aluminium foil backing. The final uppermost layer of the hangar roofs was constructed using the highly efficient Rigidal Ziploc standing seam roofing system. The 400mm wide sheets of pre-patina coated aluminium cladding were roll-formed in situ in lengths of up to 100 meters. Once formed, the individual sheets are then manually lifted into position, where they are clipped into place, and lastly, locked and sealed using an automated zipping machine. A total of 32 door leaves was required for the project, 4 for each of the 8 hangars. These were fabricated by a UK company and were manufactured to specification before being shipped to the site and installed. Each is 18 meters in height and 22 meters wide and consists of a steel framework with insulated cladding built up in situ. The lower 2.2 meters section fitted with toughened double glazing. The doors sit upon steel rails that had to be installed to an extremely exacting tolerance. 3 different types of polycarbonate sheeting were used to face selected sections of the outer surfaces of the hangar in order to allow natural daylight to enter. The rest was clad with insulating sandwich layers and aluminium sheeting of similar form to the roof. The exterior surfaces amount to a total of 80,000 square meters. Throughout the hangars and workshops, a variety of epoxy products were used to finish the flooring to ensure a hard-wearing and low-maintenance finish. This was applied with either rollers, screeding machines, or directly poured and levelled with trowels in the case of self-levelling materials. In all, 210,000 square meters had to be covered. Due to the nature of the project, extensive fire safety systems had to be installed. The deluge system of one hangar alone discharges 1,350 litres of water per second. Part of the contract requirement was to lay all the external services and pavements. These included the taxiways, ground support equipment roads, aprons and irrigation and landscaping, amongst other items. A total of 18 gantry cranes were supplied by a French company. The cranes are of various capacities in order to cope with the heavy loads required by the aviation industry. Nose docking equipment were also required to allow access to the front part of the aircraft. The stores were fitted with a state-of-the-art automated racking system. Part of the project included a bridge, fitted with 4 travelators linking the main facility to the security gatehouse. The main project took 900 days to complete and was ready for handover on the 10th of June 2006, meeting the specified handover date. The Emirates Engineering Centre became operational the next day. At the peak, there were as many as 4,000 tradesmen on site, and the entire project required a staggering 20 million man-hours. The total cost was approximately 400 million US dollars. Ioannou and Paraskevedes are proud to have been given this opportunity to prove themselves yet again in this highly competitive market.